In this video, we will learn about thrust and pressure. So thrust. So a force can be applied on a surface in any direction. A force acting normal to the surface is called thrust. So this is, let us suppose, the surface. If the force is acting perpendicular to it or normal to it, that is 90 degree from the surface, then we say it is thrust. Now, consider an object placed on a surface. The object exerts a normal force on the surface whose magnitude is equal to the weight of the object. Normal force is always perpendicular to the surface. Thus, thrust exerted on a surface by an object placed on it is equal to the weight of the object. Just like force, thrust is also a vector quantity. Unit of thrust would be Newton. CGS unit would be dyne. And the relation between dyne and Newton is 1 dyne is equal to 10 raised to the power minus 5 Newton. Or 1 Newton would be equal to 10 raised to the power 5 dyne. Gravitational units of thrust are kilogram force, that is kgf, kilogram force, or gram force, that is gf, where 1 kgf is equal to 9.8 newtons or 1 gf is equal to 980 dyne. Pressure. The thrust on a unit surface area is called pressure. Alternatively, force acting per unit surface area acting in a direction normal, that is perpendicular, is called pressure. So if F is the force acting normally on a surface area A, then pressure P is given as force acting normally to the surface area divided by the area of the surface, that is thrust upon area, right? Or I can say pressure equals F upon A, that is force upon area. Now, pressure is a scalar quantity. It is because while defining pressure, we do not consider the total force, but we're only considering a component of the force acting perpendicular to the given surface. So if it is the surface and these two forces are acting on it, okay. So this force, that is F1, will act normally, and the component of this F2 force, that is this component, that is F2 cos theta, will be applicable and not the F2 sin theta. Okay. Now, pressure depends on the surface area on which a given thrust depends upon. Like if a given thrust acts on a smaller surface area, the pressure will be more and it will have greater effects on the surface. On the other hand, if the same thrust acts on a larger surface area, pressure exerted by the thrust is less and it will have lesser effect on the surface. For example, if a boy stands on a loose sand, the thrust, which is equal to the weight of the boy, acts on a small area that is equal to the area of his feet. As a result, the pressure is more and the feet of the boy go deep into the sand. If the same boy, however, lie down on the sand, the same thrust acts on a much larger surface area, and so the pressure exerted on the sand is less. As a result, the boy does not go deep into the sand. So I can say that pressure equals force, that is thrust upon area. If the force or the thrust is constant, that is same, then pressure is inversely proportional to area. Larger the area, less is the pressure, and lesser the area, large is the pressure. Units of pressure. In SI system, the unit of force and surface area are Newton and meter square respectively, right? So the surface area of the pressure would be Newton per meter square. In the honor of the scientist Balse Pascal, the SI unit of the pressure is called Pascal and is denoted by PA. Okay, so 1 Newton per meter square is known as 1 Pascal. Remember this. In CGS system, the unit of pressure is dyne from the force and centimeter square from the meter square, where 1 dyne per centimeter square is equal to zero point 0.1 Pascal. Sometimes pressure is also expressed in the terms of bars and millibars, where 1 bar is equal to 10 raised to the power 5 pascals and 1 millibar is equal to 1 MBAR millibar, that would be equal to 10 raised to the power minus 3 bar, or I can say 100 pascals. I hope this topic is clear to you. Thank you.